Mr. Sarthak, what is the area of a parallelogram? Mr. Satya.
Sir, base upon height.
Mr. Sarthak.
The base into height.
Base into height. So now let us assume that this is the length of the parallelogram, this is the breadth of the parallelogram, and this is the height. Then the area of the parallelogram would be length into height. Is it okay, Mr. Sarthak?
Yes, sir.
Or if you are getting confused, let this be the base, and this is the height. This is the height. Therefore, area of the parallelogram is, Mr. Satya.
Sir, means I don't understand. Base into height.
Base into height. Mr. Sarthak, any doubt?
No, sir.
Mr. Sarthak, last time we had discussed why this is base into height. Do you remember the reason?
Yes, sir.
Yeah, what is the reason?
So because height is basically the width and the base is basically the length of a rectangle.
Sir, the simple reason is that a parallelogram can be divided into two equal triangles. Have you understood?
Yes, sir.
So, Mr. Satya, have you understood what I said?
Yes, sir.
See, you guys remember congruency? Or have you forgotten? Now, if you remember, this angle would be equal to this angle. Why? Because this line is parallel to this line. Mr. Sarthak, is it making sense?
Yes, sir.
Mr. Satya, is it making sense?
Yes, sir.
So this angle is equal to this angle. This is the common side. And also, what you can say is that this line is parallel to this line. Are you getting the logic?
Yes.
And therefore, this angle would be equal to this angle. Why? Because this line is parallel to this line. Sarthak, is it making sense or not?
Yes, it's making sense.
So, see, what I'm trying to say is that these two lines are parallel, and this is a transversal. Therefore, this angle would be equal to this angle. Satya, now is it making sense?
Yes, sir.
This angle, this angle, this angle, this angle. And similarly, because this line is parallel to this line, I'm talking about these two lines, and this is a transversal. This is a transversal. Therefore, what I'm claiming is that this angle is equal to this angle. Do you guys agree to this?
Yes.
Yes, sir.
So these two angles are equal, because that is the definition of a parallelogram. The opposite sides are parallel. So what we can see is that when I take triangle 1 and triangle 2, so which rule of congruency can I apply, Mr. Sarthak?
ASA.
Shabash, ASA. This is the angle. This is the angle. This is the side, and this is another angle. Satya, is it making sense or not?
Yes, sir. It's making.
See, what I'm claiming is that a parallelogram has two parallel sides. This side, these two are parallel sides. And if I take a transversal, I can take this as a transversal. This as a transversal. Let me modify this. This is a transversal. So that is what I am claiming, that this is equal to this, and this is equal to this, and this is a common side. Therefore, this triangle and this triangle, they are congruent, and because they are congruent, the area of the two triangles are congruent. Satya, any doubt?
No doubt, sir.
I'm just giving you a reason, and you can solve this by geometry also. Therefore, because triangle ACD is congruent to triangle ACD is congruent to triangle ABC by SAS. Therefore, the areas would also be equal. Sarthak, do we agree to this?
Yes, sir.
So, area of ACD is equal to area of triangle ABC. So, that is what I have said in the beginning of the lecture, that this area and this area would be equal. So, basically a parallelogram consists of two equal triangles. Mr. Sarthak, do you agree?
So it will be ASA, right?
Yeah, it will be ASA. Thanks a lot, yaar. Thank you. Yeah, correct. Mr. Satya,
Yes, sir.
have you understood what Mr. Sarthak has said? This would be ASA.
Yes, I understand.
Angle, side, angle. Mr. Sarthak, you are correct. So, ASA, by ASA, these two triangles are they are congruent, and because they are congruent, the areas are same. And because the areas are same, what I can claim is that the area of parallelogram ABCD would be equal to twice of area ADC. Mr. Sarthak, do you agree?
Yes, sir.
Now further, if this is the base and they have told me that this is the height, so area of ADC would be equal to, Mr. Sarthak, can you tell me? Mr. Sarthak,
So half into base into height.
shabash, half into base into height. This 2 and this 2 cancels, therefore area of parallelogram is base into height. Mr. Sarthak, do you agree?
Yes, sir.
So what we have done is, basically we took a parallelogram, and in a parallelogram, if this is the height and this is the base, then the area of triangle ABCD, area of triangle ABCD would be equal to base into height. Mr. Satya, is it okay?
Yes, sir.
Now, Mr. Satya, let me ask you a trick question. Now, let me assume that I do not take this base and I do not take this height. Now, what I do is, Mr. Satya, that from here I draw a perpendicular like this. Mr. Satya, have you understood?
Yes, sir.
Now, AP is perpendicular to BC. Satya, have you understood?
Oh, yes.
Sarthak, have you understood?
Yes, sir.
Then, Mr. Satya, can you tell me the area of parallelogram? Area of parallelogram. Mr. Sarthak.
I don't know.
Can you guess?
So based upon height, right?
See, in that case, what you can assume is this BC to be the base, and the area would be base into height. This would be the height. Sarthak, is it making sense or not?
No, sir.
It's not making sense. Okay. So let me draw this parallelogram like this. I think now it will make sense. Have you understood what I've done?
Yes, sir.
Now what I am claiming is that this, or let me draw it like this. Let me draw it like this. This is the height. Sarthak, have you understood?
Yes, sir.
And this is the base. Sarthak, have you understood?
Yes, sir.
Now, Mr. Sarthak, can you tell me the area of the parallelogram?
BC into BC.
Area of parallelogram would be equal to base into height. Do we agree to this?
Yes, sir.
Mr. Satya, do we agree to this or not?
Yes, sir.
Now BC is DC and height is H. Mr. Sarthak,
Yes, sir.
any confusion still?
No, sir.
So please try to understand what I'm trying to tell you guys is that if this is a parallelogram, it looks like this: A, B, C, D. Now the same parallelogram, I can shift this parallelogram and it may look like this. This is what I'm trying to tell you guys. If I shift this parallelogram will look like this. This would be A, B, C, D. But the area should remain the same, na? Do we agree to this or not?
Yes, sir.
Yes, sir.
Now in this case, the height would be this. In this case, the height would be this. Do we agree to this?
Yes, sir.
Yes.
In this case, this would be the base. And in this case, this would be the base. Do we agree? Do we agree?
Yes.
Yes, sir.
Now, because now I'm dealing with two heights and two bases and they are different. Let me call this height 1, let me call this height 2. Let me call this base 1, let me call this base 2. Do we agree to this?
Yes, sir.
Or rather than base 1, I'll call this B1 and I'll call this B2. Mr. Satya, is it making sense or is it getting confusing?
Oh, that's fine. Yes, sir.
So Mr. Satya, what will be the area of parallelogram ABCD? Mr. Sarthak?
So,
Yeah.
sir, I think DC into H, like you told us.
Yes, the length of DC is B1. So I can call
Yeah,
this
sir.
B1.
B1 into H.
B1
H1.
into H1.
Yeah.
And Sarthak, what would be the area of ABCD for this triangle?
BC into AB.
What is BC?
Base.
B2.
Oh,
Can I call this B2?
yes, sir.
So what would be the area?
Base 2 into H2.
B2 into H2. B2 into H2. Is it okay?
Yes, sir.
Mr. Satya, any confusion?
No, sir.
Mr. Sarthak, any confusion till here?
No, sir.
And Mr. Sarthak, do we agree that B1 into H1 should be equal to B2 into H2 because the area of the figure will remain the same, yeah? It can't change. Mr. Sarthak,
Yes, sir.
you need to tell me whether this is correct or incorrect.
It's correct.
It's correct. So area of ABCD will remain the same, yeah? So for example, let me take us a very simple example. So for example, there is a book lying on the table. The book is kept something like this. Yeah, this is how the book looks like. Yeah. So this is a book. Now if you look like this, if you look at the book like this, you want to find the area of the surface, this surface. Let us assume that the area is 5 centimeters square. Then you put the book on the table like this, something like this. Again, the area of the cover surface would remain the same. Na? It will remain a 5 centimeters square. Do three of us agree to this or not? Or is there any confusion still?
Sir.
Sarthak, is there a confusion?
No, sir.
Satya, is there a confusion?
No, sir.
Now I can, put the book like this also here. I can put the book like this. Roughly this is how I can tilt the book like this. This is how the book looks like now. And again, the area of the surface of the book would remain the same. A, B, C, D. This area would remain the same. It would be 5 centimeters square only. The area won't change because you are tilting the book. Do we agree to this? Are we very confident about this?
Yes, sir.
So that is all that I'm trying to tell you guys. That if you take a parallelogram ABCD, in one of the figures, DC is the base. DC is the base. But then you shift the parallelogram like this, and then the base is BC. Of course the height will change and the length of the base will change.